Hello friends, here this is the problem. U is equal to x square minus y square, v is equal to 2xy, x is equal to r cos theta and y is equal to r sin theta. Then we have to show that Jacobian of uv with respect to r theta is equal to 2r cube. So here we can see that u and v both are functions of x and y. So u, v are functions of x, y, and you can see x and y both are function of r theta. X, y are functions of r theta. So u, v are composite functions of r theta. So using chain rule, you can see here del uv upon del r theta. This can be written as del uv upon del xy and del xy del r theta. This is the property of Jacobian. Here u and v are function of x, y, x and y are function of r theta. So u and v are composite function of r theta. So when we find the Jacobian of uv with respect to r theta, so this can be written as the product of uv, Jacobian of uv with respect to xy and Jacobian of xy with respect to r theta. So first we find here Jacobian of uv with respect to xy. So from the definition this can be written as, del u upon del x, del u upon del y, del v upon del x, del v upon del y. And this is the Jacobian of xy with respect to r theta. So by the definition this can be written as del x upon del r, del x upon del theta, del y upon del r and del y upon del theta. So the product of now we put the value of partial derivatives with respect to x, y and with respect to r theta. You can see here now we put here value of partial derivative of u with respect to x, that is del u upon del x. We can see here when we differentiate u with respect to x partially, we get 2x, and when we differentiate u partially with respect to y, we get minus 2y, and when we differentiate v partially with respect to x, this is 2y, and when we differentiate v partially with respect to y, so we get 2x here. Now we, in the second determinant, you can see this is the partial derivative of x with respect to r. So with respect to r, when we differentiate, we get cos theta, and differentiation of r with respect to r is 1 here. Now we differentiate x partially with respect to theta, we get minus r sin theta. Minus r sin theta, because r is constant here, and differentiation of sin theta is minus cos theta. Here we differentiate this x partially with respect to theta, so r is constant and differentiation of cos theta is minus sin theta. Similarly, we put here the partial derivative of y with respect to r, so sin theta is constant and differentiation of r is 1 here. and differentiation of y partially with respect to theta. So r is constant and differentiation of sin theta is cos theta. Now we solve these two determinants. You can see that this 2x multiplied by 2x we get 4x square, and then minus this 2y multiplied by minus 2y we get minus 4y square, so this becomes plus 4y square. Here we multiply this cos theta by r cos theta, so this is r cos square theta minus this sin theta multiplied by minus r sin theta, we get minus r sin square theta, so this becomes plus r sin square theta. Now we taking common 4 here and r, this can be written as 4r x square plus y square cos square theta plus sin square theta. You know that cos square theta plus sin square theta, this is equal to 1. So we write here 4r x square plus y square multiplied by 1. So this becomes 4r x square plus y square. Now you know that here the given relation is x is equal to r cos theta and y is equal to r sin theta. When we add x square plus y square, so we get r square cos square theta plus r square sin square theta. Here x is given r cos theta, so square this, we get r square cos square theta, and y is given r sin theta. When square this is r square sin square theta. Taking common here r square, we get cos square theta plus sin square theta, and know that cos square theta plus sin square theta is 1, so this becomes r square. You can see that x square plus y square, this is equal to r square. So when we put here in place of x square plus y square, we put here r square, so this is equal to 4r cube. So we get Jacobian of uv with respect to r theta, this is equal to 4r cube. Thank you.